Here we go. Algebra 2, lesson 4-1. This whole unit 4, is how to divide polynomials. There's a lot of cool little tricks I'll be teaching you along the way. The first one is just kind of a warm you up type of lesson. Today's date is Thursday, October 29th, 2020. Our objective today is to do what? Looks like Jessica got it first. Quotient. Yep. Nice. Yeah. So 639 can be broken up into the hundreds place, the tens place, and the units place, the ones place. I think this goes all the way back to, I don't know, first grade, second grade. Do it for us. What?
The first one would be 600. The second one would be 30, and the third one would be 9.
Exactly. And then go and do the division for us, Wyatt.
200 plus 10 plus 3.
And therefore, that's equal to
213.
213. Of course, I can make a harder problem and it might not come out so nice. But just notice that what I'm really doing is I'm taking each of these individual digits and I'm dividing 6 by 3 to get 2. 3 by 3, 9 by 3, and just doing the division over and over again. This is going to be the same process, and I'm applying this to polynomials. One of the things I've learned as a teacher is whenever you deal with polynomials, it's really a cool way if you apply it back to numbers, because everything originates from numbers. Everything in this lesson is just this, but with polynomials. And then once I teach you a polynomial trick, like you guys know the trick that if I have a conjugate pair, a plus b, a minus b, you multiply those together, you get a squared minus b squared. That means something if you convert it back into numbers, but that's a topic for another day. Let's try this next one. Divided by x. 10x to the power 3 divided by x is what? Jade.
10x squared.
There it is. 10x squared. Why?
Because you are dividing to get 10x power divided by
Okay. Who else can explain also? Charles.
You're multiplying 10 by x cubed, so you would be, I guess, unmultiplying one of them.
Okay. That's another way of seeing it. Yeah. Another explanation, Sergio?
When you divide, you subtract the exponent.
Yeah, that's another way of thinking of it. The rules of exponents. I had the 3. Okay, what did we subtract then, Sergio, to get the 2? 3 minus.
3 minus 1.
Oh, yeah. So this must be a hidden one then. Yeah. Everyone, give me a thumbs up. You guys all know that that's a hidden one. All right. Review from Algebra 1, right? Okay. So, yeah. And then another way that hasn't been mentioned yet is really 10x to the power 3 is, as Charles said, you multiply. So 10 times x times x times x. This represents 10x to the power 3. There are 3 x's. The exponent counts how many times I have multiplied that x. In the denominator, I just have one of those x's. And then whenever things are being multiplied, you are allowed to cross cancel. You're allowed to find something in the numerator and denominator that are the same and cross them off. I'm left with 10 and 2 x's. This says there's a 10 and 2 x's. So yet another way to visualize this. Let's try another one. 5x to the power of 10 divided by x is, Jenny. It is indeed 5x to the power of 9. And negative x divided by positive x is, Andres?
Would that just be a negative x?
Close. Not negative x.
Negative x squared?
Because really you have 1 and 1, so it's x to the power of
2, right? Oh, wait, no. Wouldn't that just be 0?
0, yeah. And then anything to the power of 0 is
It's up to 1.
1. Negative 1, yeah. Very nice, very nice. And then, so essentially what I'm teaching you here is how to do basic division. How do I do 600 divided by 3? How do you do 30 divided by 3? Now we're going to put all of them together like we have up here. If I have all of these together, you can do some really quick math and you basically subtract a power. Who's got example 1 for us then? Jose?
Is it 2x squared minus 5x plus 2?
It is indeed, yep. And if you need to explain your work for this type of question, you can explain it like this. You can say, really, we had this number here, and we factored out an x, which was our last unit, how to factor out the greatest common factor. The greatest common factor for the numerator is x. The denominator was x. These two terms, I guess these two polynomials in the numerator are being multiplied. I have one tiny monomial, and I have a trinomial. These polynomials are being multiplied to each other, by each other. If they're being multiplied, I have permission to cross cancel. The x and the x cancel out. So the x and x are gone. And as Jose said, you're left over with that 2x squared minus 5x plus 3. Question, Andres?
So would you just basically do that for every problem that we're going to do?
For today?
For this lesson?
For today, half of them will work this way. Some of them you'll have a remainder, and I'll show you what that remainder looks like. Because sometimes, yeah, anyway. Example number 2, very similar. Who's got it? Give it to someone that hasn't spoken yet. I have not heard from Fernando, Josie. Josie, yeah. There it is. Thank you. All right, then we move on to example number 3, which is a little bit harder because you'll notice that that very last term, that minus 8 in the numerator, doesn't have any x. I'm curious on what you guys think you're going to do. Charles has an idea. Who else has an idea? Andres has an idea. Jade has an idea. Jose has an idea. Charles, let's go for it.
So you could put an x to the power of 0 on A8. I don't know, just to, I don't know. But that would be 7x squared minus 2x plus minus 8 over x. Oh, that would be plus 1.
Oh, plus 1, okay. So you're correct. But why did you write minus 8 over x? Charles?
Because since there's no x on 8, you're dividing x, but you don't know what x is, you're not common.
Okay, I don't understand why x is in the denominator still. Because you put an x in the numerator, x to the power of 0. What happened to the x to the power of 0?
I just did that just to show myself that there's still an x there.
Okay. Yeah, can Wyatt add on to your explanation? Go for it, Wyatt.
Well, because we don't know the value of x, we can just keep it as negative 8 divided by x, which is still true. We just haven't solved for x yet. So that we can just keep x under 8. So you don't fully simplify it, you just simplify it greater.
Yeah, that's another way of thinking about it. Yeah, nice. Let me show you a third way of thinking about it. So here we go. The third way of thinking about it is I can divide every single one of these by x individually. It's the same thing that I did up here. When I have 639 divided by 3, I can separate the 600, I can separate the 30, and I can separate the 9 into 3 separate parts. Watch how I do this down here. Down here, I'm going to say this fraction is really 7x to the power 3 divided by x minus 2x squared divided by x plus x divided by x minus 8 divided by x. If they can simplify, yay, kudos, they simplify. If they don't, you leave them. It's the same procedure that we did up above, and you can see that you do get back to 7x squared, the x to the power of 3 minus, or divided by x. You subtract the powers. Keep subtracting the powers, subtract the powers, subtract the powers. That one obviously simplifies to 1, x divided by x. And the minus 8 over x, there's nothing I can do, I just leave it. Of course, there's the other explanation just using the rules of exponents. If I have x to the power of 0 and I divide by x, I'm left with x to the power of negative 1. If you're really comfortable with your negative powers, x to the power of 1 means I'm really dividing by x. So ton of different ways that you can see this. Yeah, Andres.
Did you set that the bottom answer into Khan Academy? Like, it's like that formula that you used to bring up?
This
Yeah.
orange stuff?
Yeah, the orange. Did you type it like that? Or what?
No, you'd have to simplify it. You still need to simplify it into the blue.
So basically like the blue color.
Yeah, so this was the intermediate step. You go from the black to the orange, then to the blue. The blue is still your final step.
One more.
Yeah, go for it.
So for -8 over x, so would you put that in, like in parentheses?
Nope, just exactly like you have there. And again, you guys remember with your fractions, if I write -8 over x, that's the same thing as -8 divided by x, which is the same thing as 8 divided by -x. You can have the negative out in front, not attached to any of the numbers. You can have the negative in the numerator, the denominator. As long as there's just one negative, those are all equivalent. If I did -8 divided by -x, that is no longer the same thing. I'll cross that one out. Just as a reminder for fractions. All right, and then finally, example 4, last volunteer. Haven't heard from Fernando, have to call on him.
It's 12x minus 1 minus 7. 7 divided.
There it is. All right, and we're done. 5th of 5 for today's objective. How well can you divide polynomials by just x and then simplify the quotient? I'm seeing a question. Let me do 5th of 5 first, and then I'll get your question. 5s, a few 4s. I would say our average is about like 4.6. Yeah, what's your question, Sergio?
So what about, let's say the same procedure when you do like x to the power 2 or the power 3?
It is, yep. All right, cool. And that concludes the lesson.